Dear students, let's continue our practice on Mathematical Analysis 1. Today we'll talk about continuity of functions. Firstly, let's recall a definition of continuity at the point x0. Definition. A function y f of x with domain D is called continuous at a point x0 if the following three conditions hold. First one, the function f of x is defined. F of x is defined at the point x0. Next one, second one, there exists a limit x as x tends to x0 f of x. And the next one, third one, last one, limit as x tends to x0 f of x is equal to f of x0. So, one more time, if these three conditions hold, the function f of x with domain D is called a continuous at the point x0. If at the point x0 is disturbed at least one of these conditions, then x0 is called point of discontinuities. So if it is disturbed, point of discontinuity it will be. We have three types of discontinuity. The first one, types or kinds of discontinuity. Okay, the first one, if limit as x tends to x0 f of x exists, but the function f of x not defined at the point x0. Okay, it's a point x0. Here, in this case, x0 is called point of removable discontinuity. Point of removable discontinuity. Discontinuity. Point of removable discontinuity. Now, the second case. limit f of x as x tends to x0 doesn't exist. So we have two types in this case. If in this case exist both one-sided limits, so if exist both one-sided limits, so it means we have limit x as x tends to x0 plus 0 f of x, the right side limit, and limit x tends to x0 minus 0 f of x. It is left side limit. If they exist, and obviously they are not equal because we don't have limit here, doesn't exist our limit. It means they exist. We define exist with this symbol, yeah, this one. They exist, but they are not equal. In this case, we call the point x0 is a point of discontinuity of the first kind. So x0, point of discontinuity first kind. And now, if, so in other case, so it means at least one of one-sided limits doesn't exist or equal to infinity, the x0 is a point of discontinuity of the second kind. So this third type, if at least one of one-sided limits doesn't exist, or equal to 0, equal to infinity, or equal to infinity. So in this case, we call x0 is a point of discontinuity second kind. So we have three types of point of discontinuity. The first one is removable discontinuity, when limit f of x exists at the point x0, but f of x is not defined at the point x0. In this case, we call removable discontinuity. The second one is if limit doesn't exist. So, but both one-sided limits exist and they are not equal. In this case, we call x0 is point of discontinuity, first kind. And if at least one of one-sided limits doesn't exist or equal to infinity, x0 we call point of discontinuity, second kind. Now we will consider some examples to these types of discontinuity. Example number 1. Find the points of discontinuity determines your kind of the following functions. For example, the first function is f of x. Let's define the function signum x. So, how we define the function signum x? It is define the sign of the function. So it's equals to 1 if x greater than 0, 0 if x equals to 0, and minus 1 if x less than 0. So it defines the sign of the function. And now, so how can you find the point of discontinuity? In this case, if we draw the graph of this function, what we get here. So here we have the point 0 when x is 0. So this is this point. X is 0. And if x is greater than 1, it is 1. So it means if we have here 1, it will be this line, parallel to x o x. So now, here it is 1. This is minus 1. If x less than 0, it is minus 1. So it means this line. Yes? Till minus 1. So, in this case, we can say that that point of discontinuity is 0, because you can see here we have one-sided limits, that both of them exist. So the left side limit is minus 1, the right side limit is 1, but the function is not, the limit of the functions not exist. That's why it is the first kind of discontinuity. We call the first kind of discontinuity also jump. So here we have jump at the point x0. You can see here we have jump is the value of jump is 1 here, 1, and here also 1. So this is the answer is we have the discontinuity at the point x0 is 0, and this is first kind of discontinuity. And now let's consider the next function. So next function is f of x is x minus absolute value of x over x squared, for example. Let's find the points of discontinuity and determine their kind. So here, if we open the absolute value as x greater than 0 and x less than 0, we'll get here 0 if x greater than 0, because if x greater than 0, here we have just x minus x gets 0. And the next one, if x less than 0, let's check. If x less than 0, we get minus x minus double, so it is now minus 2x over x squared, so it is minus 2 over x just. So now let's calculate the one-sided limits. Limit as x tends to, it's a point 0, of course. Here we will check at the point x0 because this is linking point. Okay, limit x 0 plus or just plus 0, right side limit, it is 0 because the first one. The next one, limit x tends to, as x tends to minus 0, left side limit, it's equals to infinity, plus infinity here. So what we get? There was the definition of the types of discontinuities. If at least one of one-sided limits doesn't exist or equal to infinity, in this case we call discontinuity of the second kind. So here also we have discontinuity of second kind because in this case we get infinity here. So at the point x0 is 0, we have discontinuity of second kind. Let's try to draw the graph of this function. So graph is here. If x greater than 0, it is 0. So it means this part. Just xox. This one. And if x less than 0, it is minus 2 over x. This is hyperbola, so it goes like this. So we can see here also discontinuity at the point 0. And now let's consider the next function. So f of x is 1 over 1 plus 3 the power of 1 over x minus 2. Here we can see the point x0 is, the function is defined except the point x0 is 2. We will need to consider the point of discontinuity between these exceptional points where function is not defined. So here, if we consider the one-sided limits, so limit x tends to 2 left side limit minus 0, f of x, it is limit x tends to 2 minus 0, this function. So let's consider here limit of x tends to 2 minus 0, left side of 2, 1 over x minus 2. Here we have minus infinity. So in this case we get limit, or just we can write as 1 over 1 plus 3 the power of minus infinity. So it tends to 0. It tends to 0. It means we have here just 1. This is left side limit at the point x2. And now let's consider the right side limit. Limit x tends to 2 plus 0 f of x. Again, we have limit x, let's rewrite the function. The power of x minus 2. So now, one more time, let's compute the limit, right side limit of 1 minus x2 now. Now, right side limit. So it is now equals to plus infinity. If it is plus infinity, so we get here 1 over 1 plus 3 plus infinity. So 3 the power of plus infinity goes to plus infinity. So it means we get here 1 over infinity or 0. So the right side limit at the point x is 2 of this function is 0. So we get both of them, so one-sided limits. They exist and they are finite. They take a finite value 1 and 0. So it means, but they are not equal. They are not equal. So we have first kind of discontinuity or jump at the point x0 is 2. We get the first kind of discontinuity. Now let's consider the next function. F of x is x squared minus 2x over, for example, x squared minus 4. And let's consider this function. Again, find the points of discontinuity and determine their kind. So here, if we consider the denominator, we get the x is 2, except the point x is 2, the function is defined in all values of x, except the point x0 is 2. So here, what we get? If we calculate the limit at this point, limit x as x tends to 2, f of x so we can factorize it and we get x minus 2, here x minus 2, x plus 2, using the short multiplication formula. And now we have here, if we can cancel them, x minus 2 with x minus 2, and the limit of this function is now Now we get limit as x tends to 2, x over x plus 2. So the answer is 2 over 4, or half. So this is our limit. Half. But at the point 2, the function f of x is not defined. Let's recall again the definition of types of discontinuity. So there we have the first type, so it means removable point of discontinuity. So removable discontinuity point. Answer: x0, it is point of discontinuity, and it is removable discontinuity point. So x0 is 2, it is point of removable discontinuity. The point of removable discontinuity. Here we can draw the graph of this function. Let's try to draw this graph. So here we have such kind of function. So at the point 2, we get removable discontinuity point. So the function is so like this, it goes this one till 2, and beginning from 2 like this. At the point 2, it's not defined. That's why we denote by this circle. So 2 is not included to the domain of this function. If it's not included to the domain of this function, so it means in this point it's not defined, the function is not defined, but there exists a limit. We call it is the point of removable discontinuity. And now let's consider the next piecewise defined function now. F of x is x if x less than 0, x squared if between 0 and 1, and x minus 1 if x greater than or equal 1. Let's consider this function and find point of discontinuities and determine their kind. So here, since these functions x, x squared, and x minus 1 are continuous functions, they are continuous at all points, x, x squared, and x minus 1. In this case, discontinuity of f of x could arise at the linking points of this function. So here the linking points is x is 0 and x is 1. Only in these points, we will check the discontinuity. Let's check with x is 0. So for checking the discontinuity, we need to calculate the one-sided limits. Limit x tends to minus 0, the left side limit of f of x. here left side limit is, it is x left side value is. So limit x tends to minus 0, x, it is 0. And now let's calculate the right side limit of this function. So here we have right side, it is right side here x squared, because this one we get x squared, so it's again 0. You can see here 0, it's not a point of discontinuity. Here at the point x is 0, the function is continuous. And now let's check the point 1. So limit x tends to 1 minus 0 of f of x. It is the left side of 1, it is x squared. So here limit, of course, limit x tends to 1 minus 0, x squared. So it is equals to 1. And now let's consider the right side limit. So here we get limit as x tends to 1 plus 0. The right side of 1, it is x minus 1. It is x minus 1. So the answer is here just 0. So what can we say here? Here we have at the point x is 1. There exist one-sided limits, but they are not equal. The first one is 1, the second one is 0. They are not equal to each other. That's why this is the first kind, the point of x is 1, it is the point of first kind discontinuity. The first kind of discontinuity. And now let's consider the next function, again piecewise function. So decide if the function is continuous and eventually find its points of discontinuity. Okay, in this case we can also find points of discontinuity among the linking points. So it is minus 1, 0, and 1, because all of 1 are continuous functions. Okay, let's begin with minus 1 and find again one-sided limits. So firstly, at the point x is here we have limit left side limit. Okay, firstly minus 1 minus 0 f of x. It is left side limit, it is logarithm of x. So here we get logarithm of we can write logarithm of here we have logarithm of 1, so it is 0 just. Yeah, this is 0. This is just 0. And the right side limit is the right side limit is -1. Here we have this one. It is -1. So this is point of discontinuity. X -1 point of this, because there exist one-sided limits and they are not equal. So this is first kind. I will write just first kind. It means this is point of discontinuity of first kind. Now the next point, it is 0. X is 0. So here again, one-sided limits, we need to find limit x -0 of f of x. So the -0 is just 0, because here just x, so it is 0. And next one, it is right side limit of 0, +0 here, f of x. And the right side limit, it is absolute value of x, so it's again 0. It is again 0. So it means here f is continuous, because we get limit here. The limit is 0. If one-sided limits are equal, it means they are equal to the limit of this function. So continuous, f is continuous here. And the last point, it is x is 1. So here we have the following limits. One-sided limits. 1 -0 of f of x. So 1 -0, here we have absolute value of x, it's 1 just. This is just 1. Here we have absolute value of x, of course, sorry. Absolute value of x. That's why it's 0. Limit f of x, it is now absolute value of 0, absolute value of 1, it is 1. And now limit of f of x as x tends to 1 plus 0. Now right side limit, it is x cubed, and if you put 1 here, it is just 1. So here also we get a limit of this function. So at the point x is 1, the function f is continuous, because the one-sided because one-sided limits are equal. Next example. Find the point of discontinuity of the function integer part of sine x. So this is integer part of sine x. We need to find the point of discontinuity. So from the definition of integer part, the f of x is equal to 0 if x is not equal to plus minus p over 2, because if p over 2, it is 1, and integer part we need to take here, and plus 2 period of the function, period of the sign, 2pk, where k is integer number, and if it is 1 if x is equal to p over 2 plus 2pk, and minus 1 if x is minus p over 2 plus 2pk. 2 pi and k. So we can conclude that the points of discontinuity are x. They are plus minus. This one's plus minus p over 2 plus 2 pi k, where k integer number. This is point of discontinuity of this function. Okay, now let's consider the next exercise. Find a and b so that the function f of x is a continuous function. So a and b, where b is positive. So here we need to use the definition of discontinuities, the discontinuity points, I mean. When the function is continuous, if there exists a limit. Yes, so now here we have the point 0. At the point 0, it takes value 1. If it is greater than 0, it is logarithm. If it's less than 0, this function. So we need to consider the one-sided limits at the point 0. Firstly, let's consider the left side limit. We know the value of at the point of 0, it is 1. So 1, we can write here, 1 is equals to left side limit. Limit x tends to minus 0 f of x it is left side here. This is left side, this is left less than, and this is greater than 0. Left side limit is of this function is, this is logarithm. Limit as x tends to minus 0 logarithm x squared plus b squared. Here, if you put 0, it is just logarithm b squared. Or it's so we can solve here now. Logarithm b squared, it is 1. It means 2 logarithm b is 1, or b is square root of number e, because here we have logarithm b is 1 over 2 and b is square root of e. Using the second one, this one, we got b. And now similarly, using the right side limit, now find a also. Here again 1, This is value of a function at the point 0. 1 is equals to limit as x tends to plus 0 of f of x. It is right side limit of this function 1 minus cosine ax. Here we need to use the equivalency of functions arctangent x squared. Okay, using fundamental limits, arctangent x is equivalent with x, and 1 minus cosine x, we considered these examples on previous lessons. 1 minus cosine x, it is equivalent with x squared over 2. So here we will use it, and 1 minus cosine ax, it's equivalent with limit as x tends to plus 0 a squared x squared over 2, and arctangent x squared, it's equivalent with x squared. In denominator we get it. So here we have just a squared over 2. And now, so this is equals to 1, and a is here equals to plus minus square root of 2. Plus minus square root of 2. This is a. So b is square root of e. B is positive, and a is plus minus square root of 2. So for these values a and b, the function of f of x is continuous. The next example, find c such that a function f of x is continuous. Here we have two values of this function where x is not equal to 0 and x is equal to 0. So we need to be continuous, this function, they should be equal. One-sided limits at the point x 0 should be equal. So let write left side limit of this function. Limit x tends to minus 0 of arctangent x fourth degree plus x squared over x. So using again fundamental limits, however arctangent x is equivalent with x, so arctangent here I will write arctangent x fourth plus x squared, it's equivalent with x squared as x tends to 0, of course, as x tends to 0. So here the left side limit of this function is 0, because x squared over x and x tends to minus 0. It is 0 now. This is left side limit of our function. And now let's find the right side limit, and they should be equal. Limit x tends to plus 0 of this function, arctangent, again, x force plus x squared over x. So this is also 0. The right side limit is also 0. So it means C, however they are equal, to be continuous, they should be equal, the two both sided limits. So now we get that here C should be equal to 0. If C equals to 0, the function is a continuous function. The next example, find B so that the function is a continuous function. This is same with previous one, so again we need to find the one-sided limits and equating these two both-sided limits to each other, get a value of unknown parameter. Here it is B. If they are equal, if both side limits are equal, this is a continuous function. If there exists and they are equal, it has a limit. Okay, now here the main one, it is x, the power absolute value of x, the power of x. We can write the absolute value of x, the power x, as the power of number e. It is e, the power of, for example, here, not x, logarithm of absolute value of x. Logarithm, note, logarithm, just if you write just logarithm, it means logarithm is base e. So this is we rewrite our function. Then let's calculate the right side limit of this function. So it is limit x tends to plus 0. So here we have, first let's calculate the right side limit of this one. It is x, absolute value x, the power of x. So if we continue, let's use this equality, and we have e the power of x logarithm of absolute value of x. So if x tends to 0, it tends to 1. This one tends to 1. It means, hence, limit x tends to plus 0, the first function, tends to 1 plus b. Using the property of limit, the limit of sum, it is sum of limits. 1 plus b. And now let's calculate the left side limit. It is right side limit. Now left side limit. Left side limit, it is limit x as x tends to minus 0. The second function now, 1 minus, because less than 0 here, 1 minus cosine x over x squared. Again, using the fundamental limits, it's equals to 1 over 2, this one. So now we have here the right side limit, it is 1 plus b, and left side limit, it is 1 over 2. Just we need equating these two values to each other, and we get here 1 plus b equals to 1 over 2. Hence b is minus 1 over 2. So for b is minus 1 over 2, the function f of x is continuous. It was the last example for today. The next time we will continue our practice. Thank you for your attention.